So we've seen the distance formula, and we know when to use it. So now we can actually, put it to work and apply this in some example problems here. So this first one, 6, 5, and 12, 3, the distance between these 2 points, what is it? So I have the formula copied and pasted right here. So now we can properly tackle this question. So it will be equals y2, or we'll start with the x's. So x sub 2, 12, minus x sub 1, which is 6 squared, plus 3, y sub 2 minus 5, y sub 1 squared. Right? Okay, so 12 minus 6, 6 squared, plus 3 minus 5, negative 2 squared. This isn't that bad. 36 plus 4 equals square root of 40, which, if you so desire, you probably should desire to do this, because your teacher will probably take off points if you don't do this. Square root of 4 times the square root of 10. Square root of 4 is 2, so the most simplified form of this answer would be 2 times the square root of 10. Don't just stop at the square root of 40. That would not be accepted for full credit, probably, by your math teacher. Notice that, random kind of pointing this out, but notice that we're squaring both terms here in the expression. So, and we can see that here. So this eliminates any or I should point out, you can see that here. So that eliminates any possibility of ever having negative numbers involved in the radical part here, which is awesome, because we don't want, perhaps we don't want us taking the square root of a negative number. So this eliminates any possibility of that ever happening. Also, you might have, by the way, I didn't say this in the introduction video, but you might have seen the distance formula written as x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared, square rooted, right? You might have seen that before, and both are technically acceptable. Both are acceptable, but I was just like getting used to the idea of having. I like getting used to the idea of having the second one minus the first one, because we also see that in slope formula. I don't know. And we see that in other places too. It's just nice getting used to seeing that, and we might not be used to that. We might always think the first term comes first, right? But it doesn't. So I just think it's perhaps good to experience that. Number 2 here, why don't you give this a crack and come back when you've completed the problem, or if you just have no idea what's going on. Pause the video. Okay, so 5, 10, and 7, 3. This is, once again, shouldn't be too difficult. So the square root, we have x sub 2 minus x sub 1, so 7 minus 1, 7 minus 5 squared, plus 3 minus 10 squared, right? So, okay, 7 minus 5 is 2, 2 squared, plus 3 minus 10 is negative 7 squared, 4 plus 49, that's the square root of 53, which I don't think you can simplify that anymore. So this is our final answer, square root of 53. Number 3, you can give that a crack also. Come back when you have an answer, or if you're just clueless. Pause the video. Okay, so this is our last problem I'll do. Square root of 0 minus 6 squared plus 30 minus 1 squared. So negative 6 squared plus 29 squared, 36 plus 29 squared. How about that? What is 29 squared going to equal? 841. That was my phone. I don't blame you for not knowing that. If you didn't, I had to do that on my calculator also. Yes, I am not. I do not know every little math fact. I don't know all the squares. I only know up to like 15, if I'm honest. The square root of 877. How about that? Which does that have a? Can you take something out of the square root of 877? Probably not. Is 877 divisible by 16? I don't think it is. So yeah, it's most definitely not by divisibility rules. So because it's not divisible by 4, so it's not gonna be divisible by 16. Yeah, and it's not divisible by 9. You know that, and it's not divisible by 25. Anyway, so is there some square that perhaps it is divisible by? Maybe, but I don't know. So let's just say that it isn't. This is something for you to do, but I'm not gonna get involved in that because I don't want the video to go too long. So I think we have our final answer here: the square root of 877. And guess what? I am going to show you in the next video, in case you so desire, how to prove that how I talked about the distance formula being related to the Pythagorean theorem. I'm going to prove that. Prove the distance formula using the Pythagorean theorem. It's going to be awesome. I know you're going to love it. Maybe if you're interested in, you're going to want to check that out. So anyway, but that's it for this video.